Ever wondered why Uranus spins on its side unlike any other planet in our solar system? Well, you're not alone. This unique tilt with its poles almost directly pointing at the sun during summer is one of the most intriguing mysteries of Uranus. Welcome to the Oddities and Curiosities channel. Please like, share and subscribe if you like our content. Let's dive into the world of Uranus, a world that defies convention, a world that challenges our understanding of how planets behave. This celestial body's axis is tilted at an approximate angle of 98 degrees. So instead of spinning like a top, Uranus rolls around the sun like a ball. Quite the cosmic somersault, wouldn't you agree? Now, the question that's been puzzling scientists for centuries is, why this odd orientation? The prevailing theory suggests that a cataclysmic collision with an Earth-sized protoplanet could be the reason behind this peculiar tilt. This event, believed to have occurred about 4 billion years ago, could have knocked Uranus off its feet, so to speak, causing it to spin sideways. But it's not just about the tilt. This sideways spin has profound effects on how Uranus interacts with its surroundings. It influences the planet's orbital mechanics, creating a unique pattern of seasons, which we'll explore in a later scene. Also, it shapes the behavior of Uranus's magnetic field, another fascinating anomaly that sets this planet apart. Interestingly, Uranus's tilt also extends to its ring system and its 27 moons, which orbit the planet around its equator, mirroring its sideways spin. This tipped ensemble, as we like to call it, adds another layer of mystery to the enigma that is Uranus. So Uranus's sideways spin is not just a cosmic quirk, but a testament to its dramatic past. It's a reminder that the universe often defies our expectations, surprising us with its infinite capacity for wonder and awe. As we delve deeper into the secrets of Uranus, let's keep this in mind. The universe is full of surprises, and Uranus is certainly one of them. Did you know that Uranus, like Saturn, also boasts a system of rings and has 27 known moons? Yes, you heard it right. This icy giant is not alone in its cosmic journey. It's surrounded by a fascinating ensemble of icy rings and moons that add more intrigue to this tipped oddball of our solar system. Now let's talk about Uranus's rings. Unlike the bright visible rings of Saturn, the rings of Uranus are dark and narrow. They're made up of tiny particles of ice and rock, tinted with organic material, which gives them a dark appearance. Uranus's rings were discovered relatively recently, in 1977, and since then, 13 distinct rings have been identified. These rings are named alphabetically from the time of their discovery, starting from ring 6, the first to be discovered, to ring 1, the last one. And what about the moons of Uranus? Well, this tilted planet is orbited by a gaggle of 27 moons, each with its own unique characteristics. The 5 major moons, Miranda, Ariel, Umbriel, Titania, and Oberon, are icy bodies with fascinating geological features, from canyons to cliffs and from craters to mountains. Some of these moons even show signs of geological activity, suggesting they might have once been, or still are, geologically active. Here's an interesting fact. Both Uranus's rings and moons orbit around the planet's equator, mimicking its sideways spin. They all follow the planet's tilt, moving in a unique side-rolling fashion. This is unlike any other planet in our solar system, and is one of the many peculiarities that make Uranus such a fascinating object of study. So there you have it, a quick tour of Uranus's tipped ensemble. From its dark, narrow rings to its variety of moons, each element contributes to the overall mystery and allure of this sideways spinning planet. These celestial companions of Uranus surely add more charm and mystery to this already intriguing planet. In a universe where order often reigns, Uranus's magnetic field prefers to dance to its own tune. And what a peculiar dance it is. Unlike Earth's magnetic field, which aligns neatly with its rotation axis, Uranus's magnetic field is distinctly off-kilter. This magnetic oddity sets Uranus further apart in our solar system, making it an intriguing subject for scientific exploration. Now you might be wondering, how is a magnetic field created? Well, magnetic fields are born from the motion of electrically conducting fluids. On Earth, this happens in the molten iron core. But Uranus, being an ice giant, works a bit differently. Its magnetic field is thought to arise from the movement of an ocean of superionic water deep within the planet. That's water where the oxygen atoms form a crystalline lattice while the hydrogen atoms move freely like a liquid. Fascinating, isn't it? But why is Uranus's magnetic field misaligned with its rotation axis? To answer that, we need to delve into the planet's unique internal structure. The core of Uranus, where its magnetic field originates, is offset from the planet's center. This irregularity could be responsible for the misalignment of the magnetic field. This magnetic misalignment has intriguing implications for Uranus. For one, it results in a wildly lopsided magnetosphere, the region of space dominated by the planet's magnetic field. This means that the auroras on Uranus, those beautiful cosmic light shows, happen in completely different locations compared to other planets. Moreover, the misaligned magnetic field also impacts how Uranus interacts with the solar wind, a stream of charged particles from the Sun. This interaction can cause dramatic variations in the planet's space weather, potentially affecting any future missions to this icy giant. So what have we learned? Uranus, true to its unconventional nature, boasts a magnetic field as unique and perplexing as the planet itself. From its origin in an ocean of superionic water to its lopsided magnetosphere and distinctive space weather, Uranus's magnetic field is a cosmic enigma waiting to be unraveled. Clearly, Uranus isn't one to follow the crowd, even when it comes to its magnetic personality. How would you feel about a winter that lasts for 21 years? Welcome to the world of Uranus, where the seasons are taken to the extreme. No, we're not talking about a few months of cold weather or a summer that overstays its welcome. Here, the seasons are measured in decades, and they are as dramatic as they come. This extreme seasonal behavior is all because of Uranus's unique tilt. Unlike other planets, Uranus spins nearly on its side, with an axial tilt of roughly 98 degrees. This means that for a quarter of its year, or about 21 Earth years, the Sun shines directly over one of its poles, while the other half of the planet is plunged into a long, dark winter. Imagine a winter that doesn't end for 21 years. That's one long, cold season where the sun never rises. It's a world of perpetual night, a frozen landscape bathed in starlight. On the other side of the planet, it's a different story. There, it's summer and the sun never sets. For 21 years, it's a season of constant daylight, a never-ending summer where the sun hangs in the same spot in the sky. Then, as the planet continues its journey around the sun, the roles reverse. The pole that was in darkness for 21 years now basks in the sun's light, while the pole that was in perpetual daylight descends into a long, dark winter. This extreme shift in seasons is unlike anything we see on Earth. It's a testament to the incredible diversity of our solar system and a reminder of the strange and wonderful worlds that exist beyond our own. But remember, these aren't quick seasonal transitions like we're used to. On Uranus, each season lasts for about 21 years. That's right, a single Uranian year, the time it takes for the planet to orbit the Sun, is 84 Earth years. On Uranus, a season isn't just a passing phase, it's a long-term commitment. The story of Uranus's birth is as intriguing as its present. Picture a time billions of years ago when the solar system was but a swirling cloud of dust and gas. From this chaos, Uranus was born. But how did it end up with such a peculiar tilt? The most compelling theory suggests a cataclysmic collision. An object, perhaps as large as Earth, might have struck Uranus, knocking it off kilter. This violent event could have set Uranus spinning on its side, a cosmic pirouette that persists to this day. But the story doesn't end there. This sideways spin, this unique tilt, may provide valuable insights into the formation of our solar system. By studying Uranus, we might uncover clues about the early solar system, about the tumultuous events that birthed the planets we see today. The birth of Uranus is a cosmic tale of chaos and collision, one that might hold the key to understanding our own origins. Beneath its icy exterior, Uranus hides a solid core. This heart of Uranus is unlike any other in the solar system. It's not a fiery ball of molten metal as you might expect. Instead, it's a frosty enigma, a solid body of rock and ice. This core accounts for only about 20% of the planet's mass, but it's pivotal to understanding the inner workings of this sideways spinner. Its composition tells a tale of high-pressure physics and chemistry, where ordinary materials like water, methane, and ammonia are compressed into exotic forms. These substances, under immense pressure, could form a hot, dense fluid that circulates around the core, driving the planet's magnetic field. Moreover, the core's icy nature might give us clues about Uranus's past. It could hint at a violent history of colossal impacts and subsequent reformation. The heart of Uranus, like the planet itself, remains a frosty enigma waiting to be unraveled.